Hi, I saw that there was some recent interest in the jump point search practical notes that I put together, so I thought perhaps there'd be some interest in looking at how I handled lighting in the game as well. Lighting, if you're like me, perhaps is something you have decided not to do right away because you thought it was scary, but maybe it's something that you've secretly wanted to do for a while because it really helps your game look better and uh, well, frankly, it's kind of fun to play around with the lighting even as you're designing levels. And so I just kind of wanted to talk through some of the different building blocks that I needed to be able to use to build the lighting effect that I've got shown here. So this is a very simple lighting model. Go elsewhere for complex things. But as you can see, I've got a point light. It's emitting light in all directions. I don't have anything special like spotlights or anything fancy like that. But I do have a way to represent obstacles for the light as basically as just grids here. You can see that this allows it to cast shadows. And while the result is pretty simple, I think it's fairly effective. And so if you look at the different pieces that you're going to need to put together to be able to achieve that type of an effect, you're going to want to consider a few different things. First off, you're going to want to consider how you're going to handle light obstacles, and you're going to want to consider how you're going to manage lights. Now, you might have some decisions here, depending on how complex you want this to be. You may want to have some events that take care of when obstacle status changes. So did you add a new block that's a light obstacle? Did you move that block? Similarly, do you want the lights to be able to move? You'll want to consider all of those different things. And this class that I have represented here, Light Map Manager, is sort of a top-level workflow class and also is aware of both obstacles and the lights and kind of just tracks things at that level. So obstacles, light organization, some sort of a top-level workflow type of a class or something that's kind of managing that. Now, other things that you're likely going to need, you're going to need some sort of a way to track the individual lights, as well as sort of the area that they're casting around. And I found it nice to actually break that into a few different pieces. But we'll get into that in just a little bit. You're going to need some algorithms to be able to handle saying, okay, here is my light source, here are the obstacles around it, what is the area that I actually need to draw to represent the illumination. So for example, if we take a look at this, I highly recommend looking at like Red Blob Games here and their article on visibility. There's also this excellent one over here as well. And definitely look at these for some of the details, but to give a feel for the type of thing that you're going to want to represent, if this yellow light here in the center is what we're trying to portray, and we have these obstacles over here, then we're going to want something that represents the polygon that is being drawn here. Now, for those of you familiar with the different primitives that game engines and OpenGL and whatnot allow you to render, you may recognize that if we sort of treat the center point here, we actually have a triangle fan as it works around here, which is highly convenient and really simplifies some things in the storage of that. So, looking at further things that you're going to want in there, you're also probably going to want a blur shader. Now, I'm not going to work on trying to show how that works in any detail here. Other people have written much better tutorials on shaders and how they work. But as we're sort of building up the light layer and displaying it, if you don't have a if you don't have a blur shader in there, you're likely going to notice that it seems very harsh and that the result is not at all pleasing. I started without that, and I immediately added it afterwards because it made such a big difference in making the the effect a lot more realistic. So okay, so if you take a look at sort of the top level workflow on what's happening here, we have this light map manager, and the brains of this is sort of all happening here. Now, if you look at what this is doing from a very high level, there is a render call on here, and basically I'm using SFML, and the render target here sort of represents the drawing surface. The render states represent like your transforms and things like that. I've got a notion of time, and importantly, I have a pixel rect that I'm using that says here is in game coordinates what I'm actually going to render. So at a high level, the workflow that this achieves is it checks to make sure that if there's anything that's dirty, like if locations have changed or if lights have changed, that it's going to go update those. And then after that, it's going to say, okay, for the area that I'm rendering, I'm going to go find all of the lights that are actually being affected. And you may have different structures in place to do this. I ended up coming up with just a very simple, I called it like spatial dictionary or something like that, that allows you to do a bounded query on an area. And I basically take my current area that I'm looking at plus the max light radius. So it's not perfect, but it'll get you a pretty good idea of the lights that are in there that need to actually be drawn. Now, at that point, if there are actually lights that need to be drawn, the big picture here is that we create a render texture, and we're going to immediately clear that with a backdrop color. So this is sort of if your scene was being set to dark or to twilight, that's your backdrop color here. And at that point, then, we are going to render the lights onto the render texture. So we've got like the twilight color. We're going to render the lights on there. Now the lights are being rendered additively. There is a little bit of a quirk in there, but they're being rendered additively, which is a very important thing. So after we've got the twilight color or whatever and all the lights being rendered onto that surface, which again, remember, those are at the end of the day just triangle fans, then our rendered texture is ready for display, and so we get it ready for display. This work here is basically just to set up our blur shader, and then we multiplicatively draw this rendered texture onto the current scene. So again, we set the backdrop color, we additively render the lights with a little bit of a twist, and we set up our blur shader, and we multiplicatively render onto the scene, the rest of the scene. And so this rendering is happening much later. If we don't find any lights, then we just sort of take this shortcut and we multiplicatively blend our backdrop color onto the surface that we're looking at. And that's just there for caching more than anything else. All right, so let's go take a look at some of the guts of this. So as you can see here in our render, the first thing we did is we updated all the dirty lights. Now, if you look at that, that's basically going to make sure that all the obstacles have been accounted for. It's going to make sure that the lights have been accounted for. And you could structure this many different ways. The way that I chose to do it is have the light map manager be the guy that sort of knows about where the obstacles are. And so it's going to find the relevant obstacles for each given light, and then it's going to tell the light about the obstacles that are near it. Okay, so then if we actually go into the light here and we look and we see what's happening apart from our rendering routine, we'll see that it in turn passes its location as well as all the obstacles that it has been told about into this light map generator. Now the light map generator gets smack into the middle of the different algorithms that you would need to do. There are many different algorithms to calculate this field of view. The one that I chose to use was fairly simple. I thought I might have to move to something more complicated at some point, but basically I can pass in the location of the light. I'm going to pass in the outer bounds. That sort of represents a bounding box that is the max distance that the light can travel. And it also passes in rectangles that represent the obstacles. Now in this case they're just squares, but the truth is you could fairly easily expand this type of approach for other types of polygons and whatnot as well. Now if you take a look back at some of these tutorials again here, like we said, we've got our center point, and basically we're going to be looking at the points of interest, the points and the lines, and we're going to be testing for intersections along those. Again, I'm going to omit some of the details for that at this point, but the one comment I will say here is that I ended up going with an approach that at first I thought was going to be too hacky to potentially work well, but for this game it seems to be working out very well, much better than I thought. And that is, if you consider the point from your center, where your light is, to the outside on one of those points of interest. So the points, and you're thinking about how you're going to test for intersection and points that matter. One of the techniques that you can use for this is to take your ray of interest and to make a ray, quote unquote, just before it and one just after it by rotating it some small epsilon amount around it, and then sort of passing those in as possible intersection points and finding the closest intersection point. I found that this has actually been quite suitable in the game. I didn't think that using something with an epsilon based approach would give the precision that I needed, but for me that particular approach has been a good one, and it had the advantage of being simple. Now I'll leave the details in terms of how you actually want to implement that, but at the end of the day, I had a class that is able to basically generate the triangle fan that represents the cutout for that light from this light map generator, and that was very useful. You may also, like me, find it to be of interest to not only track the triangle fan, but perhaps you want to visually debug this. I mean, there's something pretty special about being able to see some of these other points here, along here, and potentially some of the lines, in being able to see to make sure that your algorithm is working properly. I tossed both the triangle fan and all that debug information into a class so that I could turn on debugging and see and make sure that things were working properly. So that worked out pretty well. So now we've hit most of the different pieces. Basically, there's checks to see if things are dirty, and we're going to go down there. We're going to try and render the triangle fan, but there are a couple other small details that I think are important to hit. One of the first ones here is, if we look at the way that the additive blending is working, it's a little bit different between the color and the alpha. And so that's just a detail that you're going to potentially want to keep an eye on to make sure that you get it to act as you would expect. Now, as far as the other details go, I chose on the light to only update the light map with some level of throttling here. Now, this wasn't strictly necessary, but I did find that this helped greatly improve performance, and depending on how often you actually potentially need to update things in cases where, say, the scene is changing rapidly and your character is not necessarily moving that rapidly, you may want to accomplish something like this as well. Now, one final note is about the flickering. Well, if you think about what the light map actually is at this point, it is literally just a triangle fan. And so you can basically think of that as a polygon that you can texture, and you can make the center brighter, and you can make the outside not as bright, and then you can literally just update the color relatively quickly on that, and that can give you sort of a nice flickering effect. I hooked that up to a little random generator, and I've been very pleased with the result. So hopefully that helps, and thank you for watching.